Alright, so in this section we want to get more familiar with conversions between the mole and the gram weight of substances. So we said that the molar mass is the mass of 1 mole of the substance, and this is equivalent to either the molecular or the formula weight of the substance in grams. It's also equivalent to 6.022 times 10 to the 23rd molecules of a substance. So our molar mass is going to serve as our conversion factor between the number of moles and the mass. If you know how many moles you have of any substance and you know the formula of that substance and you have your periodic table handy, you can calculate their mass. And if you know the mass of a sample, you can do the reverse and you can calculate the number of moles of a substance that you have. So let's do a little bit of practice doing conversions between grams and moles. So if we have the molar mass of water, we know is 18 grams because we've got 16 from the oxygen and 2 from the hydrogen. The conversion factor then between moles of water and the mass of water is 18 grams of water per mole of water. So the conversion factor then between the mass of water and moles of water would be flipped. So you can write this conversion factor in either way. So you can have grams on top and moles on the bottom, or you can have moles on top and grams on the bottom. It just depends what you're trying to calculate. So if we started and we had 0.25 moles of water and we wanted to figure out how many grams of water that is, we would use our conversion factor with the grams on top. So our molar mass would be 18 grams of water in 1 mole of water. Multiply that by 2.25 moles, and our answer would be 4.5 grams of water. Also maintaining significant figures. So we've got 2 significant figures here. Multiplication dictates that we need 2 significant figures in the answer. Since our conversion factor again is a defined unit, we don't need to worry about significant figures in the conversion factor, only in the number that we've actually measured in the lab. If we have our sample the other way, so we have grams of a substance, we can use our conversion factor to calculate how many moles of that substance that we have. So if we have 27 grams of water, for example, we would flip our conversion factor so that moles are on top and grams are on bottom. And we would say 1 mole of water over 18 grams of water multiplied by 27 grams is going to give us 1.5 moles of water. Alright, so let's do some practice. How many grams then are in 2.5 moles of silicon dioxide? So your goal is to get this into grams of silicon dioxide, and to do that we have to figure out how many grams then are in a mole of silicon dioxide. So we know we've got 2.5 moles. So we need to do our conversion factor, and if we calculate the gram weight, we'll find that an atom of silicon, if we go back to our periodic table, is 28.09 grams. We've got 1 of those, and we've got 2 oxygen atoms, each at 16. So that'd be 32 of the oxygen plus 28 of the silicon is going to equal 60.1 grams of silicon dioxide per mole of silicon dioxide. So this is going to be our conversion factor. And in this case, when we're calculating grams, and grams is our goal, we're going to want grams on top and moles on the bottom. If we multiply this out, we're going to see that moles are going to cancel, and we'll be left with our answer in grams of silicon dioxide. So if we calculate this out, we should get 150.3 grams. So then do the smell test. Does this seem reasonable? We know we've got 60.1 grams in 1 mole. We've got 2.5 moles, so this seems reasonable, our answer. Alright, so now we can go the opposite way as well. So we want to find out how many moles of sodium hydroxide there are in 15 grams of sodium hydroxide. So our goal is to calculate the moles of sodium hydroxide. And what do we know? We know we have 15 grams of the substance. And so we need to calculate our conversion factor. We need to find the molar mass of sodium hydroxide. So again, we know what 1 mole of sodium hydroxide, this is going to need to go on top because that's what we want to find. And if we take our periodic table, we can calculate the mass of a sodium hydroxide molecule. So if we look at our periodic table, we can see that there are 22.99 grams in sodium, 16 grams in oxygen, and 1.01 grams in our hydrogen atom. If we add those all together, we find we've got 40 grams of sodium hydroxide in each mole of sodium hydroxide. So we can calculate this out by a simple conversion. The grams of sodium hydroxide are going to cancel out, and we're going to be left with our answer in moles of sodium hydroxide. So in this case, we've got 0.375 moles in 15 grams of sodium hydroxide. Does this seem reasonable? We have much less than a mole weight in grams, and so yes, this seems very reasonable. So how about if we have one more problem? How many grams of sodium chloride are there in 0.234 moles of sodium chloride? So again, state your goal first. We want to find grams of sodium chloride. We know we have 0.234 moles of sodium chloride. And then to do our gram to mole conversion, we're going to want our conversion factor with grams on top because that's what we want to find, and moles on the bottom. So we have to find our molar mass then for sodium chloride. So again, if we look at our periodic table, we've got our sodium at 22.99, and we have our chloride ion over here at 35.45. So we're going to add those two together to get the molar mass. And we find that that is 58.4 grams of sodium chloride in 1 mole of sodium chloride. So moles are on the bottom, and they're going to cancel out, and we'll be left with our answer in grams of sodium chloride. So 0.234 times 58.4 grams is going to equal 13.7 grams of sodium chloride. And this seems reasonable because it's a lot smaller than the gram numbers per mole, and we only have about 1/4 of a mole present. So this seems very reasonable for our answer. These just represent some examples to help you do some conversion problems between grams and moles. In the next section, we'll start putting these concepts that we've been working on to our chemical equations.